Hi and welcome to the next video in this short series of creating an indoor navigation system. And first of all, I'd like to point out that in my environment, the minimap changed and the environment itself changed. So we'll have a kitchen, a living room, a bedroom, and a hallway now. As you can see, the target cube changed. It's now the coffee machine, and the starting point changed. It's now in the upper right corner. Besides that, everything can be used that we've done in the previous tutorial. So I would say let's start and extend the system with a QR code scanning system and a system that allows us changing between multiple targets. So first of all, we need a UI and we have to import the TextMesh Pro essential resources by clicking on Window, TextMesh Pro. I already imported it, and as the next step, we need a QR code reading system. So zebra crossing is the way to go here. There is a .NET implementation on GitHub. The link is also in the description, and in the releases section, we just download the full release of zebra crossing for .NET. After we downloaded it, there is a zip file with lots of folders, and there is a Unity folder in there. Within these folders, there are three files, the DLL, the PDB, and the XML. We'll just take them, we copy them, and put them in our Unity projects. I created a plugins folder, call it Zebra Crossing, and pasted these three files here. There is a possibility that there may be a warning in the console, but you can ignore that. Zebra Crossing will work anyways if the setup is based on everything that we've done in the previous tutorial. So I'd say let's start by checking our environment. From the last time, we see that this more or less is our area where we are moving, so we're just renaming it to navigation area and create a new empty child. We'll reset it and call it environment, because our environment will consist of multiple parts now, and we make the navigation area a child of the environment. Make sure the navigation area is static, create a new game object as child of environment, and call it navigation targets. So having more or multiple targets is quite essential. We're just moving the target cube in there, call it coffee machine target cube, and add a few more targets, more cubes, which is duplicated by pressing Ctrl D, and rename it to main entrance target cube. You can omit the target cube. I'll just name it accordingly so I can more or less every time check that this is a target cube, duplicate it again, and let's call it bedroom target cube, or whatever you feel comfortable with. Move it into the bedroom. Orientation does not have an impact, so you can also rotate it or something else. Make sure the Y coordinate still is 0, and I guess one more would be okay. Now let's leave it like that for now and check our navigation mesh. The bake properties are set. As you see, the mesh is properly baked, and if you have any problems, check the agent settings so that the agent is not too broad to pass through the doors. In our game window, we see the minimap we created last time, so we'll expand this minimap by adding some additional functionality, like a button for toggling the the navigation line, and a drop down for choosing all of our targets. So we have to modify the canvas a little bit. And there is our indicator sphere. I'll just add a new layer and call it indicator, and move the indicator sphere onto that layer so that our AR camera will not show the indicator. Make sure the top-down camera still the layer is selected in the top-down camera, and the AR camera does not select the indicator layer for showing the sphere. This is just a small adaptation. You don't have to do it at all, but it's nicer at all. So let's get back to our canvas. We'll rename it from minimap canvas to application canvas because this canvas will now be extended. So moving the image of the minimap to the left, minus 225 seems quite right. Adding something new, you go to right-click UI and where it is, button text mesh pro, and we'll call it the toggle line visibility button, like this. Adding, changing the anchor, or clicking on the anchor, hold Alt and click on the bottom center, so the button will be moved down, and we'll move it a little bit to the right. Let's say, I don't know, 275 maybe, move it up by 450. Well, that looks okay-ish. The width is 300 and the height will be 200. Well, yes, that's pretty okay, I guess. And the label text will be a font size of 40. And the text toggle line visibility. Here we go. Maybe make the font size 50. Yes, that looks pretty good. So every time we press this button, the line visibility will be toggled. And now adding a drop-down, right-click UI, drop-down text mesh pro, and call it, oh no, just move it down like before, the anchor to the bottom center, and we rename it to, how should we call it, navigation target drop-down. I guess that's okay. Position will be 275, the same as the button. The Y position 150. Make it again 300 wide, and the height should be 100 for the selected element. So when we're going down the drop-down, we have the possibility to set the options. The first option will be the coffee machine. The second option will be the main entrance. And the third option to choose from will be our bedroom. Here we go. And let's check the label. Okay, font size 35 is okay for showing the selected index. The arrow, let's make it a little bit bigger, 40 by 40, maybe. That looks okay. And within the template, we'll have to change a few settings to make it appear the right way within the content area. That seems okay. The item, the content maybe 100, because our item should also have a height of 100. And within the item, background is okay. Check mark, the label. Drop down is always a thing. Maybe the content should be 300 because we have 3 items. Well, we just can start the editor and check it in the game window. Let's see. Click on the drop down and we'll see, oh, okay, the items are pretty small and there is somehow way too much space. Let's check the template again. Make the height 300. Recheck it. Let's go. Okay, the drop down itself seems okay, but the items are not right. Let's see, content is 300, make it 100 because the content should, one item should be 100, and the check mark height is also 100, and the label, let me think, I guess the font size should be 35 or 40. I don't know, let's check it. Make it 35 at first. And here we go. Okay, that looks okay-ish. There is room for improvement, I know, but I would say for selecting everything is fine now. Okay. The next step would be to link our button and our drop-down to the code for toggling the line visibility and selecting the navigation target item. Again, I will not type the code in front of you here. I will just open the whole code and explain it. Feel free to obviously pause the video and type it yourself. So on the indicator object, there is our set navigation target script. And first of all, I'd like to point out that I've created a target class. I made it serializable so everything can be viewed in the editor window, in the inspector window, which only consists of a name and a game object for the target. Doesn't matter if it's a navigation target or some kind of QR code reading stuff target. And the set navigation target class changed quite a bit. So first of all, we have a Text Mesh Pro drop-down reference here for selecting the object. A field of navigation target objects is a list of our target class, and a NavMesh path, the same as last time, a line renderer line, and a target position for the currently selected target, and a Boolean variable which make it possible to toggle our line visibility. In the start method, everything stayed the same. New NavMesh path, the line renderer, and we just set the line to invisible by setting it the enable property to the line toggle property. And in the update method, we check if the line toggle is true and if we have a current target position that is not the origin. So if that happens, we'll calculate a path from our current transform to the target position on the NavMesh, as you can see in line 27. And if this is true, the line will have its position count and the set positions method called. Sorry about the scrolling. And so the next method is the set current navigation target, and the toggle visibility method. They are both public to be linkable in the event handlers of our UI. So the set current navigation target takes the integer of the selected value, so basically the index, resets the target position to vector 3.0, because if there is something going right and we don't have a valid target, we don't want to calculate a new path to something that's not there, obviously. And from the navigation target dropdown, from the options with the selected value, we select the current text and try to match one of our target objects by name. And if we found a new target, we'll reset the target position to its position. And if that happens, the NavMesh will calculate a path from our current position. The toggle visibility button just toggles the Boolean for the line visibility and sets the line either enabled or disabled based on the line toggle variable. So now linking the UI button, toggle line visibility button, to our code, we just scroll down, go to onClick, add an click listener, and on the object we'll drag the indicator objects, click on set navigation target and click on toggle visibility to trigger it whenever the button is clicked. And on the navigation target drop down, the on value changed event is our event that we want. So get the indicator again, set navigation target, and in the dynamic integer section select set current navigation target, so that the integer index of our drop down is copied to the parameter of our event and is triggered accordingly. At the set navigation target, I'll pause the video here for a short time. You'll just see that this changed from our previous tutorial. We have a navigation target drop-down reference here, as you saw in the code, and we just changed the list of our navigation target objects. So I'll continue here. The navigation target dropdown will be linked here in the references list. The navigation target object has a size of 3, and the first entry's name is coffee machine. The position object is the coffee machine target cube, and the same goes for the second entry, main entrance, and the third entry, bedroom. So we just link everything together. I know that there are better ways than this to do it, maybe some kind of JSON or something else. And just make sure here that the options name matches the names of the list entries on the indicator on the set navigation target, so that you can look for the targets within this list. As I said, maybe a JavaScript file or something else is better suited for this, but this is just for our small program here. So start the editor. We're trying to show what's happening. We're selecting the main entrance, click on the toggle line visibility, and as we see on the minimap and in the scene, our NavMesh already calculates the path from our current position to the main entrance, or if we change it to coffee machine, it's also calculated to lead us to the coffee machine. And last but not least, the bedroom minimap changed, and we see, okay, our navigation path leads us to the bedroom. So I'll pause the video here again. If you want to test something in the editor, it's always a good idea to have some kind of visualization that supports your debugging session. And we saw it here that if something is not working, like the NavMesh generation, path generation, or something else, it's always good to test within the editor before publishing to a device, because the debugging on the device is pretty hard. And as we need no AR camera functionality here for testing, this is one of the best possibilities to test before we build. Okay, let's continue. And let's take care of something that we haven't touched until now, the QR code reading. And for reading a QR code, we first need the image of the device camera, and the ARFoundation gives you a very good introduction on how to get the image from the camera by try acquire latest CPU image. And there is a sample code in here, so you won't need to type everything yourself. You can just more or less copy this example to your Unity project, and we'll just make slight changes here for the QR code reading. Having zebra crossing for .NET, there is also very easy example code. You can also copy this. Instead of getting the bitmap image from the hard disk drive and decode it, then we'll just use the image getting by the device camera and decode it for looking for a QR code. Usually when not having such functionality like for ARFoundation, you will use Graphics.Blit. You can, I'll also place the sample code here. You will need a render texture for this and a normal texture, and just copy everything from the camera to the render texture. I placed it here in the get image alternative. You can use the AR camera background here, a separate render texture, and maybe some kind of text to show the scanned QR code. And here you go, creating a texture to the barcode reader with using zebra crossing, calling Graphics.Blit for a render texture, create a new texture 2D where you can copy everything you got from the camera background material on the target render texture to your camera image texture, and then just tell the barcode reader to get pixels 32, sorry, decode it and check if there is some kind of result. So this would be the very simple approach for this. You can also use it, but we'll go here with the more complicated approach in QR code recenter. We have a serialized field for ARSession origin, the AR camera manager, and a list of navigation target objects, the camera image texture, and our barcode reader. For demo and evaluation purposes, I just put an update method here that checks if the spacebar is pressed, and every time the spacebar is pressed, it resets our current position to the living room, for instance. According to the example code, as you can see here on the manual and scripting API of ARFoundation for synchronously convert grayscale and color. This code is basically one-on-one. I copied it and just modified it a little bit. Register, deregister, try to acquire the latest CPU image, get the image conversion done, get the size, allocate the buffer. Here it is the first difference. We just convert it by the conversion params and the buffer, create the camera image texture, and then this image texture is used to decode with our barcode reader from the image data. And as you can see here, the image convert method is different because the unsafe keyword is used here. I personally don't like to use the unsafe keyword, so I just used another overloaded method. And after we decoded the hopefully scanned barcode from our camera image, we just tell our game or application to set QR code recenter target, and again we're just trying to find objects names within the list. I just added to lower here, and I did the same at the set navigation targets to prevent not finding targets due to typos. And if we found a target, we'll use the method session reset, which will reset our AR camera position and rotation and destroy all navigation targets. I'll just switch to the scripting AI to show you the method ARSession. Click on ARSession and scroll down to methods. And here it is, the reset. Resetting the session destroys all trackables and resets the device tracking, and everything is reset to the origin. This is very important to tell our AR camera that there is something going on, and adding an offset for the recentering based on our currently found target. And we talked a lot about the QR code stuff and so on, and now we're creating it. We create an empty game object, call it QR code recenter, something like this, and adding the QR code recenter object here, adding the ARSession reference, ARSession origin reference, and the AR camera manager, which is on the AR camera, and adding 4 new navigation target objects. Name it living room and start point for resetting everything to a starting point. The next is the main entrance, and the last one maybe just kitchen, I don't know, we'll see. Okay, in our environment we'll add a new child, new empty child, call it QR code recenter targets, and we'll just add empty game objects here. You can also add cubes here or something else with different colors, and the first one will be the living room, and we're just moving it down a little bit. Over here, this is the place where our QR code will be on the wall, and we'll just have to rotate it here. I'll pause the video again to just tell you a very important thing. The QR code itself must always face in the negative Z direction. So if we scan it, we'll basically reset our whole AR session and give the ARSession object session origin an offset, and this offset must also be rotated into the correct direction. So when placing a QR code on the wall and scanning it with the camera, the back of our smartphone where the camera is located must face into the forward Z direction, so the QR code must face in the negative Z direction from a local space perspective. So make sure to always rotate the QR code recenter targets right. And we'll just go on now with the living room QR code and setting the next one here. Create empty. Let's use the start point QR code, this does not have to be changed because it's the starting point. Create empty the main entrance QR code, which does not need any rotation at all because we're facing into the same direction. I cannot move it when it's up there. That's strange. Okay, just do it like this. Place it over here. Make sure that the real world position and the virtual position of the QR code also is correct, so there is no real offset. The last QR code will be the kitchen QR code. Just move it over here, move it a little bit down there, and rotate it around minus 90 degrees. No, minus 90 degrees, 270 degrees on the y-axis. Just checking again, living room is right rotated. This needs 270 degrees of rotation. Nice. Again, the same reason as before, the orientation must be correct. So on the QR code recenter, we're just going to reference our recenter objects, the living room, the start point, the main entrance, and the kitchen QR code. And that's basically everything. Let's check. Don't forget that we have a possibility to test in the editor with a spacebar. So I guess everything is done. Just let me look if everything is okay. Just the main entrance. Okay, we have the living room as target, not the main entrance. It doesn't matter. So if I look over here, check our ARSession origin, it's 000, pressing spacebar, and you see the minimap changed and the offset of our ARSession origin changed. And looking at the scene, it's now at the living room QR code. Yes, it's the living room, not the main entrance. Sorry about that. And here we are facing into the right direction, having somehow recentered everything now. And if we try to change the line visibility and to navigate towards our target, in this case the main entrance, everything is calculated correctly from our current position. So last thing to do is creating our QR codes. There is a website, qrcodegenerator.com, where you can just type in the name of the or URL or numbers or something else. I created QR codes regarding to the target, so every target has its unique name, like start point, main entrance, you saw it before, living room and kitchen, and the QR code will just represent it. I'll copy it into the project just for reference reasons. There is no need for you to keep the textures here. Important that they are printed out and mounted to the walls correctly in the correct measurements of the environment. So now going to build settings at our current scene, to the scenes build, check our run device, oops sorry, mouse slip, to Google Pixel in my case, click build and run, save the APK. Here we go. I'll just accelerate the video here so we don't have to wait forever. The first build always takes a few minutes to complete. And here we go. And the next video, I'll just put it in here, shows how it looks on the smartphone. So I started on the starting point. Okay, everything's here. I'll choosing the main entrance, click toggle line visibility, turn around, and as you can see, the tracking already works. There is my line. Okay, the measurement of my room is not that correctly, so we have a slight drift based on my incorrect measurement. Doesn't matter at all. So here we go to the main entrance, and as you can see, the cube is where it should be. There are enough features for correct tracking. So now we're just trying to lose the tracking, no features, camera gets somehow confused, and as you can see on the minimap, nothing moves or moves in a weirdly wrong direction. I'm scanning the QR code, the ARSession is restarted, and the offset for our camera is done, and I'll go back to the living room. Here you go. Tracking working correctly, and I'm trying to move to the coffee machine now. Here we go. There is the path, and there is the coffee machine. Same goes for every other QR codes. Just a little thing that I wanted to mention, just changing the target to the main entrance. When having the QR codes mounted on the wall, make sure there are enough tracking features after restarting the ARSession so that everything tracks correctly after starting. And if you liked the video, please like, subscribe, and comment, and give me some suggestions what you want to see next. Thank you and bye.